This is a remake of a video that I made a couple of years ago about how to diagnose ignition on your DeLorean. Several owners have posted doing those tests incorrectly, and some owners seem to not understand what the tests are actually diagnosing. So I'm gonna make this video a little bit longer and go into a little more detail about what exactly is being tested and why. First and foremost, with the exception of its low operating voltages, DeLorean ignition is 100% identical to other distributed spark ignition systems of its day. So any of the electronic ignition diagnosis videos on YouTube will also work on a DeLorean. But do be advised that some of the voltage measurements will be different. This is a thumbnail sketch about how the ignition system is wired. White leaves the bulkhead connectors and then runs over here to the resistor grid. That is 12 volts. This is my white wire with a fuse link on it. That is 12 volts that powers the ignition system, except for the module, which is wired in the fuse 1 inside the car. Now, don't get strung out about my resistor grid here. I don't ordinarily use it. I only wire it up when I need to make a video. On a stock DeLorean, white will go into one of these two tabs on the end of the resistor grid, and then white with yellow leaves the resistor grid and runs back to the ignition coil, to the positive side of the ignition coil. Okay. If you look down there, there's a little plus sign. So white with yellow goes to the positive side of the ignition coil. White with gray or white with slate, whatever terminology you want to use, goes from the negative side of the coil. See, there's a little minus sign in that terminal. Goes from the negative side of the coil into the passenger compartment to the ignition module. Now, in normal operation, what happens? This resistor grid cuts down that 12 volts on the white wire to somewhere between 6 and 8 volts on the white with yellow wire. So a stock DeLorean only has 6 to 8 volts going into its ignition coil. And that's the reason that DeLorean spark plug gaps are so small compared to other vehicles of 1981. Nearly all other vehicles are running more than 6 to 8 volts into their ignition coils, so they can have wider spark plug gaps. But stock DeLorean ignition is relatively low voltage, so you have to have the smaller spark plug gaps, or it can't reliably jump them. Now, the ignition module turns this negative wire on and off. And it does that with a floating ground. I've got a video up on YouTube that explains how the ignition module actually turns the coil on and off. But it's the same principle as the old-fashioned breaker points that would open and close, severing the ground connection. And inside the coil there are a smaller number of large gauge primary windings that go between these two terminals, and then a much higher number of smaller gauge secondary windings. And what happens is when this ground is severed on the negative side of the coil, the magnetic field that has been created by those large primary windings collapses, and that induces a high voltage in the secondary windings that are connected to the distributor lead wire, and that high voltage is then fed out to the ignition distributor, and then from the ignition distributor out to the spark plugs, where it jumps the gap and is grounded through the engine block back to the battery. There are a variety of methods that people use to verify whether their ignition system is making spark or not. You can get dedicated spark testers that go in between the spark plug and the spark plug wire. Some people will take a spark plug out and rest it on top of the engine block to visually see if they're making a spark. What I like to do is I use a timing light, and I click the inductive pickup on the distributor lead wire. I don't use one of the spark plug wires because the engine turns slowly during the starting cycle, about 300 RPM or so, and so your spark plugs will only be firing about once every 2 to 3 seconds. But if you use the lead wire that goes between the coil and the distributor, it'll be firing about every half second or so. So this is what it looks like when your ignition system is operating normally. You should see the timing light flashing on and off, and that means that you are most likely making suitable spark. This is what it looks like when your ignition system is not working. The timing light will not flash. So in this instance, I would need to diagnose my ignition system and figure out why I'm not making spark. I am going to work my way through the ignition system in the order of the components that I just showed you. So I'm going to start with wiring. I'm going to start with the white wire from the bulkheads, and I'm going to look for voltage going into my resistor grid. So that is battery voltage going into my resistor grid. Now each one of those resistors is a 1/2 ohms of resistance. So coming out of my resistor grid, I should have somewhere between 6 and 8 volts. So my resistor grid is operating properly. It is stepping down the system voltage from the white wire down to 6 to 8 volts on the white with yellow wire. I also can verify proper voltage into the coil at the coil itself. Remember, this is the positive side of the coil, has the little plus sign on that terminal, so that should be somewhere between 6 and 8 volts coming out of the resistor grid. So I have the proper voltage going into my ignition coil. Let me say something about the resistor grid. As you saw, voltage out of the resistor grid into the ignition coil was rather low, even by 1981 standards. Most vehicles of that era were running at least 10 volts into their ignition coils, and General Motors was running full system voltage in their HEI systems. So during the starting cycle, when the battery is being pulled down by the load of the starter motor, that voltage into your ignition coil is going to be even lower, and it might not be enough to reliably fire the spark plugs. So to compensate, what they rigged up for DeLoreans is a bypass that will bypass one of these two resistors. So you only have one resistor active during the starting cycle. And the way they did that is with a relay that is ordinarily mounted like right here. I don't run normal ignition, I run high energy ignition, so I've removed my relay. But on a stock DeLorean, it'll be mounted right about there, and it has 4 wires. The white wire is ganged onto this terminal, and that is what's going to actually power the bypass. The black wire is a ground. It's bolted to that bracketry that runs across the back of the engine compartment. You've got one blue with yellow wire that is the trigger for the relay, and that's attached to your starter motor. So when the starter motor is triggered, it will also trigger the relay. And then your last blue with yellow wire is what is actually connected to the bypass. So during the starting cycle, this relay gets triggered and it feeds system voltage through to this blue with yellow wire, which will bypass one of these 2 resistors. And I'm guessing it should give you somewhere between 8 and 10 volts into your coil while the starter motor is turning. If you want to measure the ignition coil itself, this is a coil that would be original to the car, and like I told you, there's 2 sets of windings in the coil. You got the large gauge primary windings that go between these two terminals, and then you have the small gauge secondary windings that go between these two terminals and then out to the distributor. So on the large gauge windings, you're looking for about 0.7 ohms of resistance or so. They're very large gauge, so they're not going to have much resistance. And then the secondary windings, the small gauge secondary windings, should be about 10,000 ohms resistance, because they're much smaller gauge and there's many more of them. So what you're looking at here, you're kind of testing the coil just like you'd test an electric motor. You're looking for abnormally low resistance in the windings, which would indicate a short in the windings. Or you're looking for infinite resistance, which would indicate that the windings are no longer connected to the terminals. Okay, now we're getting to the part of the ignition system that seems to bamboozle people or cause the most misunderstanding, and that is the electronic ignition module and its control of the coil. And I made a video, that in-depth video, that shows how the ignition module actually controls the coil, and maybe I'll post a link to it at the end of this video. But in a nutshell, in the bad old days of breaker point ignition, inside the distributor were a set of breaker points that would physically open and close like this. And every time they opened, they would sever the ground connection on the negative side of the coil, generating the high voltage secondary current. Well, our electronic ignition module uses a floating ground, but it accomplishes the same thing. It is turning the negative side of the coil on and off using voltage, just like the old-fashioned breaker points opening and closing. So what I'm going to look for is this negative side of the coil being turned on and off, the ground being connected, severed, connected, severed. And my preferred method to do that is an ice pick light. I'm going to do this test 2 times. This ice pick light, I've put an LED bulb in the handle because it reacts quickly enough that you can actually see it flashing. So when the coil is grounded, the bulb is lit up. But as the module is turning the coil on and off, you can see the LED bulb flashing on and off. Now, most people don't have an LED bulb. Remember, I wired this ice pick light up backwards. So this is positive, this is negative, because LEDs are polarity sensitive. Now, most people are going to have a traditional ice pick light with an incandescent bulb. The test is going to be the same, but it's not enough time for the bulb to go all the way dark and then re-illuminate. So you won't see it flashing like the LED bulb. What you're just going to see is it getting bright, dim, bright, dim. But it's the exact same test. So I'm grounded. And you can see the ice pick light getting bright, dim, as the ignition module is turning the negative side of the coil on and off. My car battery started running low, so I had to go get the battery charger and put it on the car battery. But like I was saying, this is an incandescent ice pick light, so the bulb will not go all the way dark, but we should be looking for the bulb to get bright and then dim, then bright, then dim, as the ignition module is turning the ground on and off for the coil. So the light does not glow steady on. If the light glows steady on, then that means that the ignition module is not turning the negative side of the coil on and off. Okay, now we're getting to what seems to cause the most misunderstanding, and that's the distributor itself, the ignition distributor itself. And it's not complicated. Inside the distributor is a set of windings, magnetic wire windings, just like an electric motor, 100% identical to an electric motor. Those are them right there. And what they do is they pass a very low voltage current, it's only a couple of volts, through those windings, which creates a magnetic field. Well, as the distributor rotates, it passes by these posts that interrupts that magnetic field. And as it interrupts that magnetic field, it causes a voltage fluctuation. And that is what is picked up by the ignition module to tell the ignition module that it's time to turn off the negative side of the coil to generate the high voltage secondary current. So what you want to test is these windings to make sure that they are intact and are not internally shorted, just like any other windings. And then we're going to use our voltmeter to emulate the ignition module, and we will actually see those voltage fluctuations as the distributor is turning. That will verify that what the ignition module is seeing is correct, wiring permitting. The first thing I'm going to measure is resistance through the windings inside the distributor that create the magnetic field. I'll use these windings first, and then I'll take a measurement on the distributor that's actually installed in my car. And just like the ignition coil, what I'm looking for is abnormally low resistance or infinite resistance. Abnormally low resistance would indicate that the coils have an internal short, and infinite resistance would of course indicate that they're no longer connected to the terminals. And I believe the spec is somewhere in the 500 to 700 ohm range. I'd have to look it up. But mine generally test around 600 ohms resistance. So as you can see, these coils have proper resistance. They are not shorted, nor are they disconnected from the terminals. Now I'm going to test the distributor that's in my car, and you'll see it's basically the same. So my distributor in the car, its coils that create the magnetic field are operating correctly. If I want to verify that the distributor is sending voltage fluctuations to the ignition module the way it's supposed to, I can use my meter to emulate the ignition module. There's a battery inside the voltmeter, and so I can send voltage using that battery through those windings just like the ignition module does. And what I want to see is the resistance values changing as that magnetic field fluctuates as it's passing by those posts. Now, you have to use the connector that goes to the distributor. I've seen people doing this test using this connector that goes inside the car. That won't work. You have to use the connector that goes to the distributor, because what we're doing is emulating the ignition module using our meter. And don't worry about what these numbers are in particular. What we're looking for is these numbers to fluctuate. If this was an analog meter, we'd see the needle moving. This is a digital meter, so we're going to want to see these numbers jumping around as the voltage that is being fed through the distributor fluctuates. So what we did was we used our voltmeter to emulate the ignition module, and we know that our distributor is operating correctly. If you want to measure something on the connector that is coming out of the firewall, you can check for voltage going out to the distributor, the coil in the distributor, which is about 2 volts or so. And then the other line is, of course, no volts, because it is the return line coming back from those coils. You got about 2 volts going out to the distributor, and then nothing on the return. Let me just say a few things about the resistor grid. I have seen owners insist that there are proper and improper terminals to attach the white and white with yellow wires to. That is incorrect. The resistor grid is not polarity sensitive. It works in either direction. So you can attach the white wire to either of these 2 terminals, and you can attach the white with yellow wire to the other one. It doesn't matter which one. And then, of course, your blue with yellow has to go to the common terminal that's halfway between those 2. Now, as I've previously mentioned, I don't use the resistor grid because I run high energy ignition. So I just use this common set of terminals to join my two wires together. Now, if I did use the resistor grid, I should not use spade terminals like these. Those are standard copper spade terminals that are rated for 200 plus degrees, 200 to about 225 degrees. And this resistor grid gets hot as blazes if you're actually using it. Mine doesn't generate any heat because I'm not using it. But if I was running voltage through these resistors, these terminals would exceed 300 degrees Fahrenheit. They would exceed the temperature rating of these terminals. I'll splice in a thermal image that was taken by a European owner who shot his terminals on his resistor grid, and he exceeded the temperature setting of his thermal camera. They were in excess of 150 degrees Celsius, which is more than 300 degrees Fahrenheit, which exceeds the temperature rating of these terminals. So if you're going to run the resistor grid, I recommend using high temperature spade terminals, which are made out of steel. And you can find them at any appliance store, because that's what you use for oven elements and hot water heater elements and dryer elements and things like that. Because if you try to use one of these terminals, it'll melt. And I have seen DeLorean owners with melted spade terminals. The factory plastic housing on the spade terminal is just all warped and turned to goo, and the spade connector inside has disintegrated because it just got so hot. In addition to everything that I just showed you, obviously the usual ignition system caveats apply. Your cap and your rotor need to be in good condition. Your plug wires need to be in good condition. Spark plugs themselves need to be in good condition. But if your ignition system is in good condition and you've passed all these tests that I just showed you, there is no reason why your DeLorean should not start without any great ado and run well. As mentioned, I'm going to put a title card that has a link to a video that I made that demonstrates how the ignition module actually turns the negative side of the coil on and off. I'm not a YouTuber, so I don't know how to make it pop up automatically, but I'll post the video link in a title card, and you can watch that, and that'll show you how the ignition module controls the coil.